Welcome to video 11, my astute researchers. Today, we're going to talk about control. So I promised you in the last video, and I know you've been like on the edge of your seat waiting to start this one because control is really interesting. A control is like having a check on it or a comparison group for your treatment group. So let's back up for a second and imagine again, you're looking at a causal design, an experiment, causal. Same idea here. Experiments are what can tell you what caused something else. Association studies can't tell you what cause is because the only thing they're doing is saying that these two variables are connected. We can't tell how they're connected. We just know that they are connected. And so you need to rely on an experiment to tell you more about how they're connected. And so you have two variables that are explaining things. One of them is the independent variable and one of them is the dependent variable. But those aren't the only variables you have. So the independent variable is the one that the researchers are manipulating or changing. So people get different levels of the independent variable. And a level might be you got 0 and the other person got 1. Or a level might be there's 10 different levels and everyone got a different amount and there's 10 different amounts. It could be that. It could be that there's 3 different levels. You get 0, you get some, or you get a lot. So the independent variable, you have different levels of, remembering, including it could be just not having the independent variable. So like just might be one, essentially one level of having a treatment and then a level of 0, there's no treatment. So that's 2 levels, but really kind of think of it as one. Anyway, so there's the independent variable, and then the dependent variable is the one that you're looking at the effect of the independent variable on. In other words, it's the variable you're measuring. And so if I'm saying that if I blink at you and then you are going to figure out if you're hungry, the figuring out if you're hungry is the dependent variable. That's what we're measuring to figure out if there's any effect of my blinking. So then those aren't the only 2 variables though that exist in the world, right? Or that it will exist in your study because your study is done in the world. There are other variables out there. And so we consider those variables extraneous. They're extra. They are the variables that might also affect what you're measuring, the dependent variable. And so you need to control those variables. So when I talked about the explanation of the reason why you're not hungry is because you just ate a chocolate cake, that would be an extraneous variable that would affect your dependent variable, how hungry you are. And so you have to control for that in your study. So if you're doing a study of blinking on hunger, you have to definitely make sure that nobody in your study has just finished eating a chocolate cake. That's an extraneous variable that you have to control. You can control it by eliminating it. You can hold it constant, etc. We're going to tell you, I am going to tell you how you do that. So one way to control these extraneous variables is to hold them constant. Now, how do you figure out what variables might even be extraneous? I mean, I think the fact that there are 12 people that live down the street might not be a variable that matters in your study. But maybe the lighting does matter. Maybe the way the color of the room is painted matters. Maybe the gender, the race, the noise level, etc. There are lots of variables that definitely might matter. One of the ways to figure out what variables appear to matter are to do a thorough literature review, because hopefully people have talked about things that they've discovered while they do their experiments. And then you can say, oh, I'm going to hold that one constant in my experiment so it doesn't affect my dependent variable. And so you're including those kind of in your experiment, but you're making them the same for all of the groups. And so since they're the same for every single group, then you know that the only thing that's different, hopefully, is your independent variable. Therefore, you can attribute any change in the dependent variable to what you did with the independent variable. You can also use random assignment to control extraneous variables. So if you randomly assign people to a group, then the idea is you figure that whatever weirdness ends up in one group will probably also end up in the other group. So there's 2 ways this works. You can figure, okay, so Let's say that 5% of the population has a thyroid disorder. And what you're doing is you're examining the impact of an antidepressant herb on people's depression. But thyroid will affect depression. And so what you could do is you could say, I'm not going to have anybody be in my study who has thyroid disorder. That would be eliminating. Or you could say, we're going to randomly assign people to whether they get the treatment or a placebo, not a treatment. So, for example, you're giving them the herbal antidepressant or you're giving them a sugar pill. And so you're going to randomly assign who gets what. And the theory there is if 5% of the population has a thyroid disorder and you have a big enough group, then you're going to have about 5% of the people in both groups with a thyroid disorder. And so that will kind of cancel out that impact because both groups are getting it. If, on the other hand, all the people in one group have the thyroid disorders and none of the people in the other group do, then having a thyroid disorder is going to be a variable that is not well controlled and it's extraneous and it might affect what your results are. One way that people do this is they do random assignment and then they compare the groups on some of these variables to make sure that they're still equal. And so they randomly assign all their people to group A or group B, and then they look at group A and B and they compare them. And so they'll say, well, they're about the same age, they're all about the same income, they're all about, the same proportion of race or gender or whatever. And so we just want to make sure that they're equal so that we know that those variables that might affect the independent variable are evenly distributed throughout both groups. You figure this out with random assignment, and then you want to see, does randomization work by collecting that data and comparing the two, like what we just said. Okay, another way to control is to include those variables. So you're going to include them and analyze them as part of your statistical analysis. And so then you're making them part of the study. So for example, you might just say, well, gender might affect this. So what we're going to do is we'll make sure we include both genders and then examine to see if there's a difference by gender. You can also just exclude them. And you do this in your exclusionary criteria. You could say, I'm not going to accept anybody with any thyroid disorders, like we said. Or you could say, I'm only going to look at men who've served in the Army. Or I'm only going to look at people who've never been on vacation, etc. So that you can exclude those variables. That's one other way to control. You want to be careful about that because the more people you exclude from your study, the higher the internal validity is, but the lower the external validity is. And that's generally how it works. The more internal validity you have, usually the less external validity you have, and vice versa. And so, to sum up, we talked about describing, predicting, and explaining. We talked about extraneous variables that affect your result and how to control them through using exclusion or inclusion, randomizing, or holding things constant.